Hello, I, Dr. Vijay Chandra Jedala, welcomes you to today's session on RAID, RAID, that is redundant array of independent disks or redundant array of inexpensive disks as part of operating system. RAID, redundant array of independent disks. The performance of secondary storage, that is the hard disk, majorly rates on the processors as well as the memory. Here it is finding two major difficulties, that is the challenges which we can say here are when the input output throughput is increased, or when the hard disk fails, the data at the time which we saved we cannot retrieve that. So to avoid such problems, the idea of redundant array of independent disk is exist. The basic idea behind the RAID is to combine multiple small inexpensive disk drives into an array to accomplish the performance or redundant goals no attainable with one large and expensive drive. This array of drives will appear to the computer as single logical storage unit or a particular drive. So here there will be number of disks which are combined and it will form as a disk drive, where this comes under the redundant array of independent disks. The main functions of RAID are storing the main functions of RAID are storing the same data in different places, that is on multiple disks, and improves the storage performance. Then comes to the it provides a better throughput and data fault tolerance. So here the performance will be accomplished by sharing the workload in a parallel among the multiple physical drives, not on a single drive. It will be worked on multiple hard drives. See here, the fault tolerance is achieved through the data redundant operation, where if one drive fails as the sector failure, the mirrored copy of the data will be found in another drives. That means a copy will be stored in the other disk, so that if in any circumstances, if one of the disk fails, the data will be saved as a copy will be saved, so that it can be retrieved. RAID appears as an operating system to single logical head hard disk, which is instead of multiple hard disks. So here it looks like a single hard disk. The controller controls how the data is stored and accessed it through the physical logical arrays. So the array means a collection. Here the array means a collection of hard disks. So here RAID RAID is a redundant array of independent disks. It is nothing but a collection of independent hard disks. So here we are going to discuss related to the different types of RAIDs, that is called as the levels of RAIDs. So RAID levels, the first is RAID levels. The first RAID level is the 0, which is called as stripping or span. RAID level 0, often called as stripping. The basic idea of this level is the idea to be stored is divided into number of parts called strips and loaded these strips across the member of disk of the particular array. Advantages of RAID 0. It is it is very fast. The performance oriented is disk mapping. The performance is better than on a single drive since the workload is balanced on array members. The method useful for high performance system. So these are the main advantages of the RAID 0 or RAID O. See here, the stripping means the division. So the main whatever the data is there from A1 to A8 is divided into 8 parts. The data is divided into 8 parts and stored in in one disk A1, A2, A3, A4, A5, A6, A7, A8. That means two different disks the data is divided and stored. But the disadvantage of RAID is no redundant data. That means there is no duplicate copy of the data. It offers no fault tolerance. So if anything fails, the entire array will affect. When a disk member fails, when any part of the disk is failed, it affects the entire array. So even though it is divided into two parts, disk 1 and disk 0, the major disadvantage here is no redundant of data. It offers no fault tolerance. When any disk member fails, it affects the entire array. Next comes to the RAID 1, which is about the least two duplicate hardwares and stores the exact same block of information between them. So it is often called as mirroring. So this concept is called as the mirroring. So it is often called as mirroring. If one of the drives failure, mirrored drive failure due to the mechanical problem or not respond, them remaining drive will continue to serve and provide the correct data. So here mirroring means the duplicacy. So A1 is here, and in disk 0 A1 is there, and disk 1 also A1 is there, disk 2 A1 is there, disk 0 A2 is there, disk 1 A2 is there, disk 3. So mirroring is the concept. Mirroring means duplicacy of the data. Disk 0, whatever the data is there, it is duplicated and stored in disk 1, so that if any of this fails, then it can be retrieved from here. So this is the main advantage of the RAID 1, which is called as the mirroring. RAID 1 uses at least two duplicate hard drives and stores the exact same block of information between them, so that it is often called mirroring. If one of the mirror drive fails due to the mechanical problem or does not respond, then remaining drive will continue to serve and provide to collect the data. So this is the advantage of RAID 1. It provides high reliability, fault tolerance, recovery from failure in simple, and it gives a good performance. Whereas disadvantage is very costly to implement since we have to implement the two disks instead of one. Everything should be duplicated because mirroring data requires minimum two drives need to implement the RAID 1. So this is all about the RAID 1, that is mirroring. The first one is RAID 0, which is also called as the stripping or spanner. That means here what it is doing, it is dividing the original data into different parts and storing in different disks. And here the original data is divided into different parts and each part is stored in a duplicate disk. Next is the most important thing, and in a real-time environment, in a different server environment, file server protocol related file transfer servers and other web servers, the major idea or major concept behind them generally used in real-time environment is RAID 1 plus 0 or 1O. that is RAID levels or with mirroring and stripping span. That means it will have the quality of RAID 1 as well as the quality of RAID 0. RAID 1O, sometimes known as 1 plus O or 1 plus 0, combines the mirroring of RAID 1 and stripping of RAID 0, offering a great solution for performance environments through the needed and added security. So here, every data, if the data is of a slot, it will be divided into 8 parts, and each part will be stored in each part will be stored in two different disks, and meanwhile this disk will be mirrored, so that if any failure occurs, if this failure occurs, it can be retrieved from here. If they have this failure, it can be retrieved from here. So it happens with the two different concepts. One is with the division and another is with the duplicacy. So RAID 1O requires a minimum of 4 hard disk drives and data is stripped across the mirror pairs. RAID 10 is fast since data can be read and written different drives simultaneously. Additionally, as long as one disk is in each mirror pair is operational, no data will be lost. Next, RAID levels. RAID level 2. It is error correcting and coding. It uses the parity. It uses the parity and it uses the concept of Hamming code. It uses the parity. P stands for parity. Redundancy scheme of RAID level 2 is Hamming code. The stripes are very small in this level, often as small as a single byte or word. The Hamming code is calculated across corresponding bit positions on each data disk, and the bits of the code are stored in corresponding bit positions on multiple disks. RAID level 2 is rarely implemented. Next comes to RAID 3. RAID levels, that is RAID 3. RAID 3 organized in a similar fashion on RAID 2, except that RAID 2 requires only a single redundant disk. RAID 3 employs parallel access with data distributed in small strips. Instead of on error corresponding code, a simple parity bit is computed to the set of individual bits in the same position on all the data disks. In the event of drive failure, the parity drive is accessed and data is reconstructed from the remaining devices. Next comes to the advantages. Because data are stripped in very small strips, RAID 3 can achieve very high data transfer rates. Any input output request will involve the parallel transfer of data from all of the data disks. Next comes to the RAID levels, RAID 3. The disadvantages are rarely to implement, only process one input output at a time. Disk 0, disk 1, disk 2, disk 3. Here the data will be stored in different disks as well as the parity will be maintained. Next comes to the RAID level 4. Here the data will be divided in different disks and parity will be maintained so that if any as an array, so that if any data is lost, it can be retrieved. So here you can see here A1, A2, A3, A of P. A of P consists of parity of A1, A2, A3. This all comes under the A of P. So if any data fails here, from this particular parity, data can be retrieved. The levels uses dedicated parity drive to protect the data disk or stripped. as in RAID level 0, the parity information for the strip is calculated and stored on the parity disk. If one of the disk fails, the information can be rebuilt from a separate disk using parity information. If the parity disk fails, the parity information is recalculated on spare disk. It is better suited to transaction input output rather than large file transfers. The main disadvantage is the parity drive can be bottlenecked during write operations. Then comes to the RAID 5. It is the most common type of the RAID. RAID 5 is organized in a similar fashion to the RAID 4. The difference of RAID 5 is that RAID 5 distributes the parity strips across the disks. RAID 5 eliminates the write bottlenecks. Only the bottleneck it has is the parity calculation process. But when the modern CPUs and software of RAID, that is not even a big bottleneck. RAID 5 requires minimum 3 disks to implement. Advantages is highest read data transmission, low rate of ECC parity disk to data disk. It means high efficiency. Here we can see the RAID 5 where the parity, there is no separate parity disk is given. In every disk the parity is part of parity. That means D1, D2, D3 will be stored as a parity in disk 0. A1, A2, A3 is stored in disk 3 as a parity. So this is about the RAID 5. The disadvantages of this particular RAID 5 is most complex controller design, difficult to rebuild in even of disk failures, high overhead of small writes to change one byte in a file, the entire stripes must be read, the bytes changed, the parity information recalculated, and the entire stripe can be rewritten. Disk failures has a medium impact on throughput. Next comes to the RAID 6. RAID 6 method, two different parity calculations are carried out and stored in separate blocks on different disks. So that this scheme needs n plus 2 disks. That means 2 disks for the parity. So here the parity, a duplicacy is going to be taken place so that you can have the more security. That means parity P is given and another parity Q is given. So here you can observe DP and DQ, BP and BQ, AP and AQ. So EP and EQ. So RAID 6, in RAID 6 method, two different parity calculations are carried out and stored in separate blocks on different disks. So this particular scheme needs n plus 2 disks, 2 for parity. The advantage of RAID 6 is that the parity extremely high data availability. 3 disks would have to fail within the MTTR, that means mean time to repair interval to cause the data to be unavailable. Finally, we are going to conclude this particular session with the summary of RAID comparison. The performance and do not need to about reliability is the based on the performance, not on reliability, is the RAID 0, that is stripping. Random input output performance and reliability, that is RAID 1 mirroring, where mirroring there is a chance of duplicacy. Capacity and reliability RAID 5. Sequential input output and maximize capacity is RAID 5. So among all the RAID levels, RAID 5 is mostly used for the sake of capacity, reliability, sequential input output and maximize capacity. Hope you all understood well all the different concepts of RAIDs, RAID 6, RAID 5 RAID 4, RAID 3, RAID 2, RAID 0, 1 plus 0, RAID 1 and RAID 0. Hope you all understood well. Thank you. Thanks a lot.